Go over number one. Number one, when I look at that it's a U-shaped curve, the graph, because all it wants me to do is identify the type. So my answer is going to be a one-word answer or one, maybe two-word answer. So if I see a U-shaped type graph, and I remember my notes from last class, it says a U-shaped type graph, and if we think back to Algebra 1, a U-shaped type graph is always going to be a quadratic function. So all you have to put is quadratic for the answer. This is the graph. It looks like the picture of what a quadratic would look like because that graph is in the shape of a U-shaped curve. Okay, let's go to number two. Now number two looks kind of different. Number two is the newer type function that we have been studying and learning about this year. All right, so we see that the graph is in the shape of a V. Also, last class, we reviewed all the different four types of functions that we will talk about this year. So a V-shaped graph is going to give me a word that actually has a V in the word. Absolute value. This is an absolute value graph because the graph is in the shape of a V. Right? So make sure you identify a U-shaped graph is going to give you a quadratic. It's not a line, so we know it's not linear. It's not a horizontal line because we know it's not constant. So a U-shaped graph is going to bring us back to last year and recalling those old things that we learned last year. It's a quadratic equation. This quadratic equation is going to continue also now in Algebra 2. A V-shaped graph is the new shape of the graph that we're learning this year. A V-shaped graph gives us absolute value. The V in value reminds me of how the graph should be shaped. All right, now let's go down to number three. Graph each function and identify the domain and range. I'm actually going to use these grids to graph on these two types of functions on top of them, just so I'm not having to erase everything that's on this screen. So the first function says f of x equals the absolute value. So I just gave away kind of what the shape of our graph is going to be. We just talked about this being an absolute value shaped graph. So an absolute value of x plus 2, right? Also on last class, we reviewed those parameters of how we can transform or translate an absolute value graph. So we know that the graph is going to be a V-shaped graph. That's number one. But then let's go also and talk about the transformations. So I'm going to say f of x equals the absolute value of x plus 2, and that's the graph. So what happened to this graph is it added those parameter transformations. Let me change it to another color. So last class we talked about how our transformative equation is going to be f of x equals a times x minus h plus k. So we have an a, h, and a k that was added to our parent function f of x equals the absolute value of x. This is the mama function. This is how the function can change to. And they chose to change and add a 2 inside of the brackets with the x. So what did they transform? They added a h value. We see that this 2 took the place of the h in our transformative function. So they added an h value. So we think about it. What does h do? What did Miss Jackson say that h can do to your graph? H is going to either shift your graph left or right if you go back and review the notes from last class. So if my h value shifts it left or right, then I also remember as long as it's inside the absolute value or parentheses, if we think back to last year, if it's inside the parentheses, we have to think the opposite direction. So if this is a plus 2, it actually shifts the graph to the left. Most of the time we think positive 2 is going to move it to the right, but this one actually shifts the graph left to the left. We know the graph is going to move left or right. So now we have to choose which direction or verify in our calculators. This graph actually shifts the parent function to the left 2 units. So I'm going to draw up here our parent function in blue. We know it's a V-shaped graph. There's my V. Now I'm going to switch colors to red, and I'm going to draw the transformative function. So now we just said we know this graph right here. We pictured the graph without even having to use our calculator. Should shift to the left 2 units. So I'm going to move this blue function 1, 2 units to the left. Put my vertex, and now I'm going to draw my graph that direction. That's what happens to our graph. Now we're going to actually verify this in the calculator. So I'm going to pull up my calculator. All right, here's my calculator. Is it plugged in to where I can tap? No, it's not. Okay, so I have this graph already in my calculator. I'm going to click on the home button to delete everything out. So I'm going to click on home. I'm going to go over to new. It asks me, do I want to save any unsaved documents? Click no. That clears out anything else that anybody else that has used your calculator has put in that calculator. So I'm going to click no, and it starts me over fresh. So now I can go back to the home screen. I could have went from where I was at, and I'm going to go and click on graph. All right? Now, you see from last period, and it should have deleted this out. It has my parent function, f of x equals the absolute value of x. That's the red graph. That's my original graph, my mama function. And then our new function that the problem just gave us was the absolute value of x plus 2. That's our blue function. How I know it's the blue function? Because the equation is written in blue. All right? Now let's look at what happened to the mama function. The parent function shifted to the left 1, 2 units, and then it drew. So that's exactly what happens, is what we talked our way through on that problem, number 3. All right? Let's go back to where we were at. Give me a second. All right? Now let's look at number 4. And we're going to do the same process. We know, let's picture, what type of graph is this? Well, I see it has a negative. I see it has a square. So what's going to be the shape of any graph with a square at the top? Any graph with a square at the top is going to be that U-shaped curve. It should be a quadratic. All right, so we know the shape should be a U, but now we have to figure out what does these parameters that they added do to the U-shaped graph. I see they added a negative in front. I also see they added a net -1 in the back. So if I'm thinking back to last year, where we transformed functions in Algebra 1 with your teachers from last year, our parent function is f of x equals x squared. That's any quadratic parent function. And then my transformative function is going to be f of x equals a times parentheses x minus h squared plus k. The exact same thing we just saw in absolute value, where a either stretches or compresses or reflects, h shifts it left or right because it's inside parentheses, and k moves it up or down. So when I look at this negative, the negative is either going to stretch it if it's a number that's greater than 1, it's going to compress it, make it wider if it's less than 1 but greater than 0, or a can also reflect it. Since that a is a -1 or a negative, it's going to reflect over the x-axis. So I'm going to draw up here again my parent function, y equals x squared. And that's ugly, but y'all get the idea. And then I'm going to switch to red. And I'm going to do the first thing. This negative is going to reflect it over the x-axis. So now it's going to be facing open downward. A smooth curve. So that's the first thing that happens. But now I still have this -1. So -1 in terms of A, H, and K, which one of these values do I think the -1 is considered as? The -1 is outside the parentheses. It's not in the parentheses. So the -1 is probably a K value. So that means this graph, K moves it up or down. This graph actually moves down 1 unit. So I'm gonna switch to one more color, green, and I'm gonna move this red graph down 1 unit. And put my vertex here, and now I can draw my green graph. So the green graph, green stands for go, that's gonna be the actual graph of my new function. And we're gonna verify it also in the calculator. So it is important that you get calculators when you walk into class and you actually go through and see the picture of what we're wanting you to be able to graph. All right? So let's go through and we graphed it, let's put it in the calculator. And then we're gonna talk domain and range. All right. Let me clear this out. Negative x squared minus 1. All right, so I want to clear out these V-shaped graphs, so I'm going to click on Home, go to New. It didn't delete anything. I'm going to do that one more time. Home, I'm going to go over to New. It's not asking me the question. If it asks you, on y'all's it should ask, do you want to save any unsaved documents? Click No. And it's going to clear everything out. Okay? So from there, I'm going to go and click on Add Graphs. And I'm going to type in that function. So that function was negative x squared minus 1. And I'm going to hit enter. Now this blue graph should match our green graph that we drew. So it looks like we started out with a blue graph that was opened upward. We then, in red, reflected it over the x-axis. And then finally, in green, we shifted it down 1 unit. So yes, our green graph did match up with this blue graph that they have on the picture. All right? So make sure you're able to go through those steps. Make sure you're able to go through and calculate how the graph is going to look without using the calculator as a crutch or a guide. I want you guys to be able to visualize how these graphs should somewhat look. All right, now let's talk domain and range. We'll start with this one since it's up. So when asking me about what's the domain of this function, so we're going to do the domain of number 4 first. Domain is talking about my x values. So when I'm writing my domain D for x, which means what are my x values? Our x values are included all along our x-axis. So they want to know what are all of the x values for this continuous function. Because I know this graph is going to keep getting lower and lower and lower, and it's going to keep moving. As it's getting lower, it's going to keep moving further to the left because it's going to get wider and open down at the bottom. Same thing on the right side. As it keeps getting lower, it's also going to keep getting wider, which means it's going to cover all of these x's. So that's why when I draw a graph, I always put arrows down here at the bottom. I want you to see that this is not only getting lower, but it's also going to expand and get wider. So if I'm trying to list all of these x values to the right as it's getting lower and lower and lower and wider, and also for the left as it gets lower and lower and wider, my domain is all real numbers. Because even though the graph is not facing upward, it's going to get lower, and so it's going to touch every single x value over here to the right and every single x value over here at the left. It's going to touch it slowly, but as my graph gets lower, it's also going to expand and get wider. All right? So our domain is all real numbers. All real numbers means every single number that's real is going to be hit by the x values on this graph. Now let's look at our range. So our range is our y values, correct? So y values, we should be looking at the y-axis only, all right? When we're trying to picture how many y values is this graph going to touch. Well, what y value do we know right now that it is touching? Well, if I'm looking at my y-axis, I see it's not touching any positives, but it starts at not 0, but it starts at actually -1 for y. So I'm going to put y, and then I'm going to put a -1 over here. because I know I'm comparing all of my y values to -1. So in terms of -1, where are the rest of my y values? They're below -1, which means they're less than -1. So I'm going to put my y values for my range has to be less than, and it can equal -1. This is your domain and range for this graph. All right? I'm going to go back real quick and I'm going to review the domain and range.